Hello guys, this is Madhav again. So today we are going to discuss about insertion sort. Basically, before getting into insertion sort, we need to just know something about sorting, right? So let me just open my Paint. Now, so we will just give some values right here. So 5, 7, 5, 7, 11, 1, 3. So this is a data, a set of values is called as a data. So the sorting is nothing but the arrangement of numbers in a proper order, either in a ascending order or in descending order. So the ascending order is from small to big and descending order is from big to small. So to perform this sorting techniques, we need to just know some basic things like ascending and descending order, right? So as we know, the ascending order for this is 1, 5, 7, sorry, 1, 3, 5, 7, 11. So this is ascending. This is ascending order. And then let's just get into descending order, that is from the reverse of ascending 11, 7, 5, 3, 1, descending. So this is a basic sorting for a set of data, that is in ascending order or descending order. So okay, then now let's just see what is meant by an insertion sort. So the basic definition of an insertion sort is a sorting mechanism where the sorted array is built having one item at a time. The array elements are compared with each other sequentially and then arranged simultaneously in some particular order. So this is a very basic definition for insertion sort. So let me just get into an example so that you can just understand a little bit clear. As we are discussed about this ascending and descending order, now let me just sort the values by using the insertion sort. So insertion sort works on the basic principle of ascending and descending orders. So let me just give some values: 5, 4, and then 10, 1, 6, 2. So now basically this is my data. So let me just place it like an array of data. So it would be a much more clear. So it is arranged in the form of an array. As we can now see, this is just a group of data, but it's not properly in an order position. So we need to perform sorting technique to just bring this to its normal position. So let us just consider this index as I, and then to perform insertion sort, we need to just remember two things, that is sorted place, unsorted place. So now this is sorted place at present. So we need to just take the initial value as a sorted for the first time, and then this whole thing is unsorted. Sorry. Yeah. So this whole thing is unsorted and the only one value is sorted. So we need to just perform some activities like we need to just compare the one of the element in an unsorted with the sorted place, and we need to just arrange them in a proper order so that finally the sorted place will just occupy the whole array so that it would look much clear in a sorted order. So without confusion, let us just take one of these values. So this is J. Let us consider this as J. So okay, now we need to just perform the activity like this. So we need to just take one of this value and then compare with the I position. Then if we can just see this 5 is greater than 4, as 5 is greater than 4, so they will just interchange the places. So now we will just get a confusion, like in a normal words we can just say like interchanging things, but in according to a programming language, if we need to just interchange things, we need an element which is called as temp. So we need to just take this value 4 to the temp position and make this clear. So this shouldn't contain anything. This is only for the external purpose, as 5 is greater than 4. So now we need to just bring the 5 value here. So after that, the array position will be like this. Initially, it is empty, 5, 10, then 1, 6, and 2. So initially it is empty. That is, uh, initially one of its position is empty. So let me just draw it in the top of in the type of array. So one of its position is empty. So we need to just place this temp value here. As we had just satisfied this condition, 5 is greater than 4. So we need to just bring this value here. Now I am writing 4 here. So like this now, as I said before, only the first element is sorted place. Now this two nodes are sorted and this is unsorted place. So now we need to consider the value of 10 with this both things. So now the temp value is 10. So now if we just compare the 10 with this both values, as 5 is less than 10, right? As 5 is less than 10, so 10 remains in its same position, and then so the array will just repeat like this same. So array will just repeat in this same position. And then now this is the sorted and these three are unsorted. Now we need to just check the value of one with this three, as now we can just see one is less than 10 and also one is less than 5. So if we can just see if the values of its first thing is greater, then we can just proceed with this first technique, and then if it is lesser, then we need to just decrement the value of 5 and we need to check all the nodes in that array. So one is less than 5 and then one is less than 4. So now we are having no elements before 1, before 4. So we need to just place the value of 1 at 4. Yeah. Now the arrangement will be 1, 4, 5, 10, 6, and then 2. So we need to just arrange this in the form of array. So now we can see here it is sorted till third node. So now it is sorted till fourth node. Now we are remaining with 6 and 2. So we need to just compare the 6 is less than 10. So left position. 6 is greater than 5. So it is greater than here. So we need to just place these things in between 5 and 10. So the values will just sort like this: 1, 4, 5, 6, and then 10 and 2. So it will just sort like this in the form of array. And then it is sorted till here and we are remaining with one and only one last node. That is 2. 2 is less than 10. 2 is less than 6. 2 is less than 5. 2 is less than 4. 2 is less than 1. This is wrong. 2 is greater than 1. As 2 is greater than 1, so we need to just place the element in between 1 and 4. The last greater than and smaller than elements. So the element should be placed in between 1 and 4. So the order will be like this: 1, 2, 4, 5, 6, 10. So this is a very basic insertion sort, which is very easy while compared to remaining sorting techniques, but it is not much efficient because it is just comparing only one of its element at a time. So it's not so much efficient when compared to other sorting techniques. So this is a very basic example for this sorting. And now let me just show you the algorithm. So the algorithm is nothing but it is just same in any language, that is either in Java or in C, so whatever it may be. So let me just copy this and let me just paste it here. So yeah. So now if we can just see for I is equal to 1, I plus plus, I less than and I plus plus. N is the size of the array and I is equal to 1. As initially the position of I is, so we can just name like this: 0, 1, 2, 3, 4, and then 5. So it will be in the indexes of the arrays will be in the form of this. So initially I should start from 1 and then j should start from 0. So I less than and I plus plus. So it should increment till the last node of the array, and we need to just store the value of each I node in temp as we had just discussed it before. So then j should start from I minus 1, that is from its 0th position. So if the value of j is greater than or equal to 0, and it need to just satisfy both conditions, and so this while loop is just defining like the value of a, either its index should be greater than 0. So jth index is nothing but this values. So index should be greater than 0. Minus 1 is not possible for j, right? So it should be greater than 0, and then a of j, that is the value of the jth index, should also be greater than temp, that is a of 5. So in initial, a of 0 should be greater than a of 5. So if it is possible, then a of j plus 1 is equal to a of j minus minus. Now we can just see if it is greater, then we are just leaving in its same position. So it will just sort in this manner. So it will just sort in this manner. And then a of j plus 1 is equal to temp. So we need to just store the values like this. And this is a very basic algorithm for storing, so for sorting the elements by using insertion sort. Thank you for listening.